Hello, welcome. Let's begin with the section B, that's the paper 2 of the BEC 2025. The question 1A, given that P is a set of multiples of 3 and Q is positive even numbers, which these two sets are subset of the universal set, a set of x such that 1 is less than x and x is less or equals to 20, where x is a counting number or is counting numbers. We have to list the element of the intersection of the two sets and find the subset of those uh, intersection. So first things first, let's list the element of the individual set. We are having multiples of 3. You know, multiples of 3 has no end. So we have to continue listing, but we are going to cap it at the universal set. So seeing this is part of the mother set or a subset of the mother set, we cannot go beyond what? 20. So multiples of 3 begin with 3. 3 times 1, 3. You multiply by the counting numbers. So times 2, 6, 9, 12, 15, 18, 21. And 21 happen to be bigger than 20, which is the universal set. So we end it there. Then we go for the set what? Q, which is also positive even numbers. Which still has to end at 20, not beyond 20. So the even numbers 2, 4, 6, 8, 10, 12, 14, 16, and what? 20. That is numbers that are divisible by 2 without a remainder. Then let's see what the mother set is. We could have started with the mother set so that it will serve as a boundary for us to list the subset, but all the same. Now, this is a number between 1 to 20, 20 inclusive. This sign here meaning 20 is part of the element of the universal set. But this sign without the equal sign mean 1 is not part, but the number after 1, which is going to be counting numbers after 1 will be 2, so 3, 4, so ending at what? 20, counting from 2. 1 is not inclusive. All right, so first part of the question is asking you to find the intersection of these two elements, two sets. The element we can see in P at the same time see in what? Q. So starting from here, okay, since this is the smallest one, starting from here, 2 is not there, 4 is not there, 6 is there. So the first number will be 6, 8, 10, 12. I have the 12, 14, we have what? 16 and 18. I think that is all. So the element of the intersection of P and Q becomes 6, 12, and what? 18. All right, then for the second part, we are asked to list the subset of P intersection Q. What are the various subsets that we can get? Now, let's see. Subset is just a smaller set out of the bigger set, if I can put it that way. Then in listing subset, remember we have a singular set, which is unit set. Single element, you pair them, then you triple them if you get a chance. Then an empty set is part of a subset. Then the set itself is also part of the subset. So we begin with the empty set as a set with no element, then a set with one element, then there will be 12, then there will be 18. The next thing is to pair two of the elements. So I am going to pair 6 with 12. I can still pair 6 with 18. I think that's all. 6 with 12, 6 with 18. Then we go for 12 with 18. That's all. So let's go for the set itself. 6, 12, 18. But let's see. To find a subset of a set, we only have two exponents, the number of what? Elements. So here is going to be 2 exponent what? N. And n is the number of elements. So if there are 3 elements, 3 is here. 2 exponent 3 give you 8. So let's check whether we have the 8. Then we can move on. So 1, 2, 3, 4, 5, 6, 7, 8. So you can see we have the required number of what? Subset of a set of 3 elements. Alright, I get the concept is clear. Listing elements of multiples of 3 which are subset of the universal set, then also even numbers. Finding their subset is also clear by you. Thanks for watching. Like, share, comment, subscribe, and come for more.